Okay, so we talked a little bit about amateur satellites, low Earth and geostationary, um, the Keplerian information, modes on satellites, a little bit about hardware and operations. So there's a lot of people. Morning, Clyde.
I want to make sure you got to close the gate today.
How do I do that?
Full gate, you pull it, there's a chain and a lock.
Oh, okay.
The storage barn back here, spasms. Yes, and skills.
All right, I'll give it a shot.
The front door.
There seems to be a lot more interest in doing satellite operations. We've got a few people in the NASA club that do a lot of it. They're AMSAT members. In order to be able to do it, you have to know where the satellite is, even if it's a geostationary. For the low Earth satellites, those are moving pretty fast, so you have to be able to track it. And of course, correct for Doppler shift as it's moving toward you and away from you, all at the same time. You know, it takes 3 hands to do it, unless you got a really good setup with a as-hell tracking. There are actually computer applications that will do that for you and show you the path. And most of those, well, I think all of them, you have to input what's called the Keplerian elements. And they publish, ARL puts one out, I'm not sure if it's every day, but it's pretty frequent, for a lot of the different satellites, and it'll show all the orbital numbers that you need to put into the program. This is a little section of one of the ARRL ones, and it shows for, well, it's decoding information up at the top, and then for each satellite, they'll have these parameters that part of this decode at the top. If you kind of spend some time, you can figure out what all those numbers actually are. So what are Keplerian elements? Most of the amateur satellites are LEOs, or low Earth orbit. So like I said, you have to track them as they move. They tend to operate in either ascending or descending. You go north to south, south to north. And if you look at any of the computer plots showing them, you'll see that kind of sine wave as they're circling toward the pole or around, so you get that effect. If it's going south to north, they call it ascending path. Descending path is just the opposite. So what is the direction of an ascending path for an amateur satellite? It's a test of your short-term memory. There's a geostationary satellite. I don't know if there's more than one. They only talk about the QO100, which is an amateur satellite that's geostationary. So you don't have to do the tracking. You just have to be able to know where to point to it. So what type of satellite appears to stay in one position in the sky? Satellites have transmission modes. It's called satellite mode. And it's defined as the uplink, downlink frequencies. So it's always uplink / downlink. So if you see it represented as a U/V, it means the uplink is on UHF and the downlink is on VHF, and vice versa. V/U is uplink is VHF, downlink is UHF. So it's kind of like a repeater offset, except we're talking two different bands instead of offset frequency. So what is meant by the term mode as applied to an amateur radio satellite? What do the letters in the satellite's mode designator specify? The three? Well, when all these ones, okay, what's the prior? This just shows the where the amateur satellites operate in this little section here from they call L bands, which is 23 centimeters all the way up to 40 gigahertz in the, I guess, up to the extended high frequency band, or except whatever E stands for. Oops. What's the answer to that? Degrees. Most of the satellites that are doing FM actually operate like a repeater. There are some that have linear transponders, and there's some that have inverting linear transponders. Typically, the transponders will do all the modes: FM, CW, single sideband, PSK, which is a digital mode, packets, which are digital. And they receive it on one frequency and they retransmit it another band of frequencies. And they can do multiple signals at the same time. It is, or spread out. If it's an inverting linear transponder, it means that they mix the signal and they shift the frequency. So you see the difference product between the two. And everything comes out inverted. So it makes a difference when you try to receive it, because you're getting an inverted signal frequency-wise. It's like looking at lower sideband. Everything's reversed. And the Doppler shift is also reduced because of that inversion. I believe them, but I didn't really look into why that's. It kind of makes sense, but I haven't looked at the mechanics of it. Which of the following types of signals can be relayed through a linear transponder? Three. No. How is an upload signal processed by an inverting linear transponder? What did you say? No. Which of the following is characteristic of an inverting linear transponder? One thing to keep in mind is transmitter power. Since the satellite is limited on its actual transmitter output, if you send a very strong signal, it's going to try to transmit an equivalently strong signal. So that takes away from the power capability of other signals that it's trying to transmit. So you're supposed to think, yes, yeah. Don't make friends. That's one of those things where previous questions where you're supposed to look at the beacon signal to see what your power is, compare it, what it should be, and all that good stuff. I'm sure you remember that one, right? Why should effective radiated power, ERP, be limited to a satellite uses a linear transponder? Now, storing forward, a lot of these satellites will allow you to send a signal like packets, and it will store it until it is over a station, a receiving station that can actually download. So, it could be halfway around the world where you both can't see the satellite at the same time.
Guessing there would have to be something in that message that tells them forward. I mean, maybe.
Well, I think it has to be contacted. Well, that's a good question.
I would think that he's trying to call.
Because if you're just receiving it, yeah, I don't know how you would trigger the download. Unless it's two-way communication, you actually have to request it. I haven't done satellite, so I don't know. I'll have to ask one of my satellite geeks. Which of the following techniques is used by digital satellites to relay messages? Store and forward. What's the purpose of digital store and forward functions on an amateur radio satellite? You don't have to know how it works. Quite a few interesting phenomena. Satellites rotate. Because of that, you get a varying signal, depending on how it's rotating. So if the antenna is, say it's got dipole antennas on it, as it rotates, since they're linearly polarized, that polarization is going to be changing. They call the effect spin fading, or spin modulation. And they also talk about it being Faraday rotation. In either case, in order to receive it without the signal coming and going, you need a circularly polarized antenna. Typically, when you're doing satellites, there'll be cross Yaggies that are thin, out of phase, so that you can pick up the signal regardless of what its orientation is. What type of antenna can be used to minimize the effects of spin modulation and Faraday rotation? I think they really should call that a cross-polarized. But yes, I guess you can make a circularly polarized. I think some of those spiral types.